we will be discussing in this lecture is handover. So cellular systems requires handover procedures because single cells will not cover the whole service area. Typically, a cell will cover up to 35 kilometers in countryside and few hundred kilometers in cities. The smaller the cell size, the faster the movement of the mobile station through the cells. The mobile station can maximum move at a speed of 250 km per hour and still handover can take place. If the mobile station is moving beyond 250 km per hour, then handover may not take place successfully. So handover should not cause a call drop. That is, during the time of handover, the call should not drop. If the user is talking over a phone at that time, then during the time of handover, it should not create the call to cut off. Okay. A GSM aims for maximum handover duration of 60 millisecond. That is, GSM tries to do the handover within 60 millisecond. There are two basic reasons for handover. So why handover should be done? There are two reasons. The first reason is the mobile station may move out of the range of a BTS or a particular antenna. Okay. So what happens? The received signal may decrease continuously until it goes below the minimum requirement for communication. When the mobile station is moving out of range of BTS, the received signal may keep going down. At one point, it will go less than that of the minimum requirement of communication. Okay, that is one reason. The signal is getting low. That is one reason for handover. The second reason can be error rate may grow due to interference. You have good signal, but still due to some interference or noise, it is creating a lot of error and the error is getting increased. That is second reason. The third reason is the distance to the BTS may be too high. Okay, the distance to the BTS may be too high. Okay, because of these effects, the quality of the radio link may reduce and the transmission may become impossible. So all these three reasons put together comes under the first reason for why handover should be done. Because basically there are two reasons for handover. So the first reason is radio quality may reduce. The quality of the radio link may reduce and it may become impossible for communication. The radio link quality reduces because of several reasons. First reason is the mobile station moves out of range of BTS or antenna. So the received signal level decreases. The second reason is error rate. And the third reason is distance of the BTS increases. Okay. So because of all these reasons, the quality of the radio link may decrease and it may not become possible to communicate. Okay. So this is the first reason for handover. The second reason for handover is the wired infrastructure like MSC and BSC, MSC or BSC may decide that the traffic in one cell is too high and shift some mobile station to other cells with a lower load. So here handover is done for load balancing. Here handover is done for load balancing. So there are two cells. In one cell the traffic is too high. In the other cell the traffic is very less. So the MSC or BSC may decide to shift some of the mobile stations from one cell to another cell. So because of that also there may be a handover. So in the second case here, the handover is happening for load balancing. Okay. So there are four different types of handover. So let us discuss that. The first type of handover is called as intra-cell handover. Intra-cell handover. So, so this is the example for intra-cell handover. So here handover happens within a cell. Here handover happens within a cell and could the reason is maybe because of narrowband interference, the transmission uh, may be impossible in a certain frequency. So the BSC may decide to change the frequency. See, currently this mobile station may be working at some frequency, say X, but in that frequency X there is lot of interference, so the communication is getting difficult. So so the MSC, so the BSC could then decide to change this particular frequency of this mobile station. Instead of X, it may ask it to try with Y frequency. So it is in the within the same cell only, but its frequency is getting changed. So that type of handover is called as intra-cell handover. The second type of handover is intercell or intra-BSC handover. Intercell or intra-BSC handover. So, so this is a typical handover scenario. Here what happens in the sense the mobile station moves from one cell to another cell. So this is the second case. The mobile station moves from one cell to another cell, but it stays within the control of the same BSC. But it stays within the control of the same BSC. This BSC controls both the cells, this cell and this cell. So the mobile station is moving from this cell to this cell, but it is in the control of the same BSC. So the BSC then performs the handover. Here the handover is done by the BSC, okay, and it assigns a new channel in the new cell and releases the old one. So it provides a new channel in the new cell for that particular mobile station, and the old channel in the previous cell will be released. So this is called as intercell or intra-BSC handover. It is moving from one cell to another cell, but it is within the same BSC. Third type of handover is called as inter-BSC and intra-MSC handover. Inter-BSC and intra-MSC handover. So this is the third type. Here the mobile station moves from one cell to another cell within the same MSC but different BSC. Here the mobile station moves from one cell to another cell and also from one BSC to another BSC but within the same MSC. Okay. So because BSC only controls a limited number of cells, sometimes GSM also has to perform handovers between cells controlled by different BSCs. So this handover actually will be controlled by MSC. Inter-BSC or intra-MSC handover will be controlled by MSC. And the next type of handover we have is inter-MSC handover. It is from one MSC to another MSC. The handover may also require between two cells belonging to two different MSCs. Okay. So these are the various types of handover that are possible. Intracell, intercell, inter-BSC and inter-MSC handover. Fine. The next what we will be discussing is for providing all necessary information for a handover, MS and BTS both perform periodic measurements of the downlink and uplink quality. Okay. See somehow we have to identify, somehow GSM should identify when the handover should be done. When the handover should be done. So for that purpose, MS and BTS will periodically measure the performance of downlink and uplink. Okay, what is the quality of downlink and what is the quality of uplink? That MS and BTS will periodically check. Okay, and these measurement reports are sent by MSC about every half second. Every half second, MSC is going to send this uh, mobile station is going to MS. Mobile station is going to send this update. Okay, and it contains the quality of the current link used for transmission as well as quality of the certain channels in the neighboring channels. So the point is when the handover should be done, that should be identified. For that purpose, MS and BTS they periodically measure the quality of the downlink and uplink. Okay. So these measurement reports are sent by MS. So MS sent these measurement reports about every half second. Every half second, MS sent this measurement report, and this report contained the quality of the current link used for transmission as well as the quality of the certain channels in the neighboring cells. Now the next concept that we'll be discussing is how handover is done, when the handover will be done. So here we can see this graph, it clearly shows. So this mobile station is currently connected at this point, at this point of time, it is connected with BTS Volt. It is connected with BTS Volt. Now let us assume that this mobile station is moving. Okay, it is not. It is traveling from one place to another place. The person who is carrying this mobile station is traveling from one place to another place. So as he moves, as this person moves, what happens in the sense, at this point, this is the signal level. So as the mobile station moves, the signal is getting decreased, and at one point it reaches the handover margin. So this is the handover margin. So if the signal goes up to this point, if the signal reduced up to this point, then there will be a handover. Then there will be a handover. It is the mobile station will be disconnected from the old BTS and it will be connected to a new BTS. So that is called as handover. Okay. So so when the signal strength becomes uh, equal to handover margin, then actually the handover will take place. Okay. So so this is about how handover was being taken place. Right. Okay. So actually this particular figure it shows uh, typical behavior of the received signal when the MS is moving from one BTS to another, that is from BTS old to BTS new. Okay. So the handover decisions here does not depend on the actual value of the received signal. The handover decision does not depend on the actual value of the received signal. Okay. That is the handover is not based on the received signal's value. Okay. So but it is based on the average value. But handover decision is based on the average value. Okay. So BSC collects all values uh, like bit rate, signal levels from uplink and downlink. Uh, uh, BSC collects all values from BTS and MS and calculate the average values. Calculate the average values. These values are then compared to threshold, that is handover margin. Okay. So BTS will collect, BSC collect all signal information like error rate and signal levels from uplink and downlink. These values are then compared to threshold, that is handover margin. Okay. So, so and then the decision will be taken whether handover should be done or it should not be done. So this is how handover takes place in a GSM. Next thing that we'll be discussing is The, so this basically represents something like a timing diagram for how handover takes place. So there is a mobile station. So as we already discussed, the mobile station will keep on send the mobile measurement report. The mobile station will keep on send the measurement report uh, about the quality of the uplink and downlink connections, and also about the neighboring channels details. Okay, this information mobile station will be keep giving to BTS World. BTS World will in turn communicate with uh, BTS World will will in turn pass on this information. Okay, so BTS World together with its own, the BTS World forward this to BSC World. Okay, BTS World, the measurement report is sent by MS for every half minute, and this is received by BTS World. BTS World will in turn send it to BSC World. Now BSC World will decide whether handover should be done or not. At this point, whether handover is required or not, that will be decided by BSC. If handover is required, then BSC will send a HO required, that is handover required. Okay, it will send a handover required to the MSC, and MSC will in turn send a request to BSC new, and BSC new will now allocate the channel, and also it will activate the channel. Okay, channel will be allocated, and also channel is activated, and its activation is acknowledged. Okay. So now there is a acknowledgement for HO request. Previously there is a HO request, now there is acknowledgement for HO request. Then there are HO commands, then there are HO commands. So now the link is established between the mobile station and the BTS new, between the mobile station and the BTS new, and the handover is completed through this command. So there is a HO complete from BTS new to BSC new. Again there is a HO complete from MSC to BSC old. Sorry, there is a clear command from MSC to BSC old, and another clear command from BSC old to BTS old. Okay, and then there is a clear complete from MSC to BSC old, and from BSC old to BTS old. So so basically this diagram shows how handover is happening from one BTS to another BTS. So so what we have discussed is mainly we have discussed the how handover is taking place. Okay, handover procedures. Why it is important in the sense because single cell do not cover the whole service area. Each antenna has a range of 35 km in countryside and 100 meters in few hundred meters in cities. Okay, so smaller the cell size, faster the movement of the mobile station. It can move up to 250 km per hour without compromising the service. Okay, so then we have discussed the different types of handovers, and then we have discussed the handover decision, how threshold plays a role here. Then we have discussed the handover decision depending on the particular graph, depending on the timing diagram. Okay. So that's it about handover. Thank you.